Good day, my friends. Welcome to today's video. Remember to like and subscribe if you find this content to be helpful. Today, we are going to our next lead code question in our study plan. And today's problem is greatest common divisor of strings. So let's go right ahead and start. For two strings, S and T, we say that T divides S if and only if S is made up of T. That means that T is concatenated with itself more than one times. So given two strings, string 1 and string 2, we need to return the largest string x such that x divides both string 1 and string 2. So in order to solve this problem, we need to check that the concatenation of string 1 and string 2 is equal to the concatenation of string 2 and string 1. That will help us to know if there is any common divisor among them. If we look at this example, uh, if we look at our example, string 1 is ABC, ABC, string 2 is ABC. So if we concatenate these two strings from both directions, we should be able to get the same result. If not, that will tell us that there is no common divisor of the two strings. So in a nutshell, if you were to define the greatest common divisor of a string in layman's terms, we would say what we are looking for is simply a repeated pattern that can form both strings. Okay, so we are just looking for a string that when it's repeated, it can form both strings. So let's get into our editor and try this out before we come back to lead code. So I'm using Dataspell. Dataspell is an IDE, so you can use whichever you want, but for me, I like this one. So I'll just create a new notebook. I'll call it GCD of strings. All right. So I'll just reduce this panel. So I'll define a function here, GCD of strings. And then we are getting two strings, string 1 and string 2. So like I said, the first thing is to make sure that we check that when we concatenate both strings both ways, that means that if string 1 plus string 2 is equal to this other one. So if they are not equal, that means that we don't have, that is string 2 plus string 1. If they are not equal, we simply return an empty string, which means that we don't have a common divisor. So if that's not the case, we try again. We try again another option. We say if string 1 is the same as string 2, then that means that our common divisor is string 1. Again, we check if, so here we want to use recursion to just iterate through the remainder of the string until we remain with our common divisor, and then we return that common divisor. So the way we do that is first we check which string is greater than the other. So if string the length of string 1 is greater than the length of string 2, then we repeat this process. GCD of strings, but this time we slice string 1, so we just say string 1, but from since the string 2 is the shorter string, so we just take the length of string 1, the length of string 2. So from that point onwards to the end of the string. Okay, so that's how you do that in Python. And then, so we are looking for string 2, right? So we are just taking a portion of string 1 and checking that string 2 can divide that remaining portion, and then we repeat that process again. So if that condition satisfied in any of these checks, then our recursion function will be stopped there, and the result will be returned. And then otherwise, in case string 2 is greater than string 1, then we just do the same thing. But we do it with a longer string. So GCD of strings. So instead of doing it for string 2, we do it for string 1, and then here is string 1. But then what I see we are using length here many times. So maybe it will make sense if I store that somewhere, so that we I just like doing this. Length of string 1 and length of string 2 respectively. You can just use them like this. All right. So this should be able to give us our answer. So we'll just test it with what we have in our problem. So we'd say ABC with ABC. So let's just return GCD of strings. So the first string is ABC ABC. The next string is let me run this and see what we get. Good. So it's giving us ABC as the answer. If we try it with the next one, good. Our answer is AB. So it should be working fine. AB as defined here. Let us try the other third one before we go to run our solution in LeetCode. All right, it's an empty string as specified here. So I think we should be doing fine. And as usual, the best way to find out is to just go to LeetCode and try to run our solution. So against the test cases that are provided by LeetCode, just reduce this panel and indent it properly. Then we test it out. All right, so this should be GCD of strings. It was named differently here. Let me just run that again. So this would be self dot. Right, so let's try to submit our answer and see how it performs. All right, so we beat 58% and 63%. Not very bad though. I think maybe there's a better solution, but at least it works. So so the time complexity of our solution should be O of n. where n is the length of the longer input, in the length of the longer input. This is just because in each recursive call, in each of the recursive calls, we progressively reduce the length of the longer strings by slashing a portion of it. So the number of recursive calls is limited by the length of the longer strings. That's why we are saying that it's linear. Okay, so the time complexity is linear with respect to the length of the longer string. Same thing to the space complexity, where n is the length of the longer input string. So this is because with each recursive call, we create a new substring by slashing a portion of the string. So as the depth of the recursion increases, so the more times we call our recursive call, multiple substring are stored on the stack, but it's still linear because the total space usage is still linear with respect to the length of the longer string. Okay, so yep, both our solutions run in O of n, both in time complexity and space. Thank you so much for watching today's video. Make sure to like and subscribe and share it with your friends. I'll see you in the next video.